design of this maybe in the left. Now, if and
Hello students, welcome to my YouTube channel VRacademy. Here we are here to discuss about the various topics of digital electronics. We have already discussed about the sequential circuits, and we have gone for going for the explanation of all the types of flip-flops and all. The last topic of the flip-flop is conversion of the flip-flop. So we have to look forward that how one flip-flop is converted to other flip-flop. Now, in order to know about that, we have to follow few steps, and if we are following those steps, we'll be able to design any kind of flip-flop. I mean, you will be able to design any kind of flip-flop with the help of anything else. I mean, any other flip-flop. So that is the way we have to understand it. But we need to remember these steps, not to remember, but if you are practicing it twice or thrice, you will be able to learn what exactly we are doing. Okay, so what are those steps? The steps are very because I have done it many a times, I can recall it. But if the same process, I mean, if you will be going for doing various numericals or questions related to that, you will automatically will be able to remember all those steps. Now, what is the first step? The very first step during the conversion of the flip-flop is to find out which is the available flip-flop and which one is the required flip-flop. I mean to say, you need to find out what is available with you and what you need to design. This is what is available and required flip-flop. Available flip-flop is your, that is one is given in the question, and required flip-flop means you have to go for the design of that one. So once you are able to determine that, this is the very important step, because if you are making the mistake in that one, available or required, the whole steps are going to be, or of no use. You will be, your question will be invalid. So this is very, very important step. You need to find out which one is available flip-flop and which one is required flip-flop. Now, once you are done with that, the second step is to write down the characteristic equation of required flip-flop. It's a simple thing, characteristic equation of the required flip-flop. So you need to write down Qn, then inputs of that required flip-flop, and from there you need to derive the next state, and you have to make a table out of that one. Now, third step will be, with the help of the present state and the next state that you have obtained just right now, in the second step, will be utilized in order to write the excited input of the available flip-flop. Whichever flip-flop is available, you need to write the excited input values of those with the help of present state and next state of the required flip-flop. Now, once you are writing that, after writing that, you have to go for designing the K-map for each of the excited input, and you need to solve that. Now, when you are drawing the K-map or when you are writing the K-map should be drawn for the excited input in terms of present state and next state, present state and input of the required flip-flop. You need to make a K-map for excited input of available flip-flop in terms of present state and inputs of required flip-flop. Now, once you are done with that, you need to solve that K-map, and after solving, you need to draw the diagram. Now, how to draw the diagram? The first thing is you will draw the available flip-flop, and whatever output or whatever Boolean expression that you have obtained after reducing the K-map, that should be designed over there. Now, it might be a possibility, because I am telling it in the terms of steps, you might not be able to get it. What exactly sir is telling and what is being done. It is just verbally sir is telling these are available, required, characteristic, excitation. So all these things are becoming bit complex. So in order to resolve that, we'll try to solve a numerical or solve a question. If you will be able to solve that question and learn from therein, you will be able to understand what exactly being written in the steps. So I have taken a question, design JK flip-flop using SR flip-flop. So this is the question, design JK flip-flop using SR flip-flop. So what was the first step? I have already said you, the first step is to find out which one is available and which one is required flip-flop. So we'll write down available flip-flop, which one is available? You can comment in the comment box which one is available with us. It is nothing but SR flip-flop. SR flip-flop is available. And which one is required flip-flop? What need to be designed? So required flip-flop is your JK flip-flop. So you need to know this, and this step is very, very important, because sometimes it might be coming as a, I mean, just changing the format, the question will come. Convert JK flip-flop to SR flip-flop. So at that time, your available flip-flop becomes JK and required flip-flop becomes SR. Convert, if convert word will come in your question, then you have to think it. I mean, this step is very, very important. If you are making the mistake in this one, your all steps will be going to have a mistake. So this is very, very important. Once you are done with that, what was the next step? You need to write the characteristic table of required flip-flop. So characteristic table, I have already said you during the explanation of the flip-flop that here the required flip-flop is JK. So for characteristic equation, we'll take the present state, J and K, and with the help of all these three, we'll be able to determine, or we have to determine what? Qn plus 1. So in order to do that, we'll go for, now these are the three inputs. These are the three inputs. So tell me how many combinations are possible. 8 combinations are possible. So we'll write those combinations in form of 4 zeros, then 4 ones, then 00, 11, 00, 11, and finally this is 01, 01, 01, 01. Now once you are done with this, you need to write the value of Qn plus 1. Now the question comes in your mind, how to remember or how to recall a characteristic equation. You need not have to remember characteristic equation. You have to just recall the truth table, and truth table of that too of just the simple truth table of JK flip-flop. I have already said you that whenever we are writing the characteristics table, we need not have to focus on the present state. We have to only focus on the inputs, and with the help of that, we'll be able to write it. So 0, 0 is no change. No change is last state. Last state is 0, so we'll write 0. 0, 0, no change. I mean, no, whatever there is in the last state, same will remain over here. 0, 1 is reset. So 0, 1, 0 is set. So I'll write 1. 1, 1 is toggle. Toggle means last state complement. So 0 complement will be 1. Then 0, 0 is last state. Once again, we will have 1. Then 0, 1, we will have 0, 1. 0, 1 is reset. So we'll have reset. 1, 0 will have set. And 1, 1 will have toggle of the last state, that is 0. So we'll be getting this as the characteristic table of the required flip-flop. Now once we are done with this, what was the next step told? The next step was you have to write the excited values of the inputs of the available flip-flop. So excited input of available flip-flop means we need to write about S and we need to write about R. Now here I want to tell you one thing, guys. I want to tell you one very, very important. During the design of any kind of sequential circuit, there is a humongous requirement of this excitation table, and there is a pattern to remember it. I mean, I am following a particular pattern in order to remember the excitation values of all the different types of flip-flop, all the flip-flops. So how to remember that? I'll tell you first, and then I will write about this one. How to do that? In excitation table, you might be knowing that two values are always fixed. That is Qn and Qn plus 1. It is always fixed. Qn and Qn plus 1. And it will definitely have the 4 combination, that is 00, 11, and 01, 01. These are the combinations. In other format, 0001, 1011 is also fine. Now after that, you need to remember what are the excited values for SR, D, JK, and T. So how to remember that? See guys, if you are following this pattern now, you will be remembering this for your lifetime. You will always be remembering this for your lifetime. So excitation table. So what you need to do? You need to remember 0, 1, 0 cross, 0, 1, 0 cross. You see, I have come like 0, 1, 0 cross, 0, 1, 0 cross. You match it up, you will be finding out the excitation table of SR is this much. After that, we have to go for D, excitation of D. So excitation of D is same as, just remember this, excitation of D is same as Qn plus 1. Excitation of D is same as Qn plus 1. So it is 0, 1, 0, 1. Done. Then you need to go for JK. You need to go for JK. Okay. So you need to go for JK. For JK, you just remember this SR, same thing. 0, 1, cross, cross. Here it was remembered as 0, 1, 0 cross. Here it will be 0, 1, cross, cross. And from the bottom, 0, 1, cross, cross. That's it. This is about the excitation table of JK. And the last one is T. So this is your T, and for T, I am saying you just the simple thing, XOR Qn and Qn plus 1, that is the excitation table of T. So 0, 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0. Sorry, 1, 1 is 0. So this is the excitation table of T. Now, this excitation table is very, very important, because from here on, whatever thing we'll design in sequential circuit, there is a need of excitation table, and this is the best way by which you can remember all the excitation table in a single table. I think it is gettable. 0, 1, 0 cross, 0, 1, 0 cross, Qn plus 1 is same as D, D is same as Qn plus 1. JK is 0, 1 cross cross, 0, 1 cross cross, and T is XOR of Qn and Qn plus 1. I think you have got it. Now once you have got it, you see here, using this one, because we have to write about SR, so we'll only focus on SR, and you will tell me in the comment box that what we have to write. So it is clearly written over here also, with the help of present state and next state of the obtained in the above step, means obtained in the characteristic table, we have to write the excitation input values of the available flip-flop. We have to write the excitation input of the available flip-flop. So we'll do that. 0, 0. So you can say that the value is 0 cross. So I am writing it 0 cross. 0, 0. Once again 0 cross. Then 0, 1 is 1, 0. Then 0, 1 is 1, 0. Then 1, 1 is cross 0. Then 1, 0 is 0, 1. Then 1, 1 is cross 0, and then 1, 0 is 0, 1. So we are able to write the excited input values of SR. Now after this, once you are done with excited input values, next we'll be going for K map. Now K map of what need to be drawn? Draw the K map for each of the excited inputs, means S and R. We need to draw the K map for each of the excited input. So K map for S. K map for S will go like this. K map for S. Okay. This side I am writing Qn. This side I am writing JK. Why I am writing JK? It is clearly mentioned that draw the K map for each of the excited input of available flip-flop in terms of present state and inputs of the required flip-flop. So present state and inputs of the required flip-flop. So this will become Qn bar, Qn. This one is J bar, K bar, J bar, K, JK, JK bar. Similarly, we'll go for K map for R. Okay, we'll go K map for R. The same thing will be repeated over here. We'll have Qn bar, Qn, then J bar, K bar, J bar, K, JK, JK bar. Okay, this side we are having Qn, and this side we are having JK. Now after going for just drawing the cells of the K map, we'll be putting up the values. So 0, 0, 1, 1. So 0, 0, I am not writing 0 because it is not needed. 0, 0, 1, 1. Then cross 0, cross 0. Cross 0, cross 0. So this is all about the values. Similarly for R, cross, cross. So cross, cross, 0, 0, 0. 0, 0, 0. And then 1, 0, 1. So you can clearly visualize over here that there are, this one is one pair and this one is one pair. Nothing other has to be used. Don't care, we are not going to use. So if there is only one pair, can you tell me what is the value of this pair in comment box? So S value will come out from this side, it is Qn bar, and from this side it is J. Similarly for R, we can write it as, from this side it is Qn, and from this side it is K. So this is about the values of the K map. Reduce the and get the Boolean expression. We have got it. Now coming to the last step. Finally, draw the block diagram of available flip-flop. This is the last step. So what we need to draw? We need to draw the block diagram of available flip-flop. So available flip-flop is SR. So we'll draw it. This one is R. I'm just negative triggering it. You can do it anything else. This is clock. This one is S. This one is R. This one is QN. And this one is QN bar. So this is our available flip-flop. After that, and make the connection according to the Boolean expression obtained in the above step. So whatever we have got it over here, according to that we have to make the connection. So S connection will be QN bar J. So I'll take QN bar from here. I'll take QN bar from here. And I'll take QN bar from here. We'll have J from here. AND gate. This is our J. QN bar J. You can see that this is QN bar, this is J. Similarly, QNK. So I am taking this is from QN from here, and I'll take a AND gate once again because I have to get the dot of QN and K. So I'll take K over here, and from here I'll have the connection of QN. Okay, and connect this to R. Now this is from here. You can see that this is our required flip-flop. Okay, this is the required flip-flop. You can clearly visualize that this is the required flip-flop. This is your QN bar. All the connections are being done. This is the final JK flip-flop. So this is how we are proceeding. Now you can easily understand what we have done exactly. We have gone for firstly finding out available flip-flop, required flip-flop as per first step. Then for second step, we have gone for writing the characteristic table for required flip-flop. We have written it for JK. After that, with the help of present state and next state of required flip-flop, we are writing the excited input values of available flip-flop. That is this one. After that, we have gone for drawing the K map for each of the excited input in terms of present state and inputs of required flip-flop. After drawing that one, we have got the values of both the excited inputs. After that, we have gone for final step, that is for the drawing. Always take the available flip-flop first. We have taken it available flip-flop, and from there, according to whatever Boolean expression you have obtained, just make the connection, you will get the final done. I mean, you will be able to get the required flip-flop design. So this is all about the explanation of conversion of flip-flop. You need to go for each and every type of combination in order to have the conversion. You can design it from T to JK, JK to T, D to JK, JK to D, SR to D, whatever connections or whatever questions that you are taking in your consideration, you try to solve that. If you are finding out, and you need to follow these steps, these are the steps you need to follow. If you are finding out any difficulty, you can come up with that in the comment box. If you are having any kind of difficulty, or if you have any kind of suggestion that it could be made better or it could be done with more precision, then your suggestions are highly viable for us. But I think this is the best method to solve a conversion of flip-flop. Thank you for joining. We'll be joining with you in the next video with the other sequential circuits. Thank you very much.